So hello everyone, Science this side, and today we are going to start off with our second week of Statistics 2. I hope so that you have revised your first week, and without further ado, let us begin the second week and let's see what's in it for us in the second week of the course. Okay, so let's begin with the second week. Just give me a minute. Let me just be able to annotate things. Yeah, all right. Okay, so let us start. Let us begin. Okay, okay. So let us begin with a question that will be able to clear our concepts and which will be very much important for our future learnings as well. I mean, we have already done this, and now let's apply it to a greater extent. Okay. So what does it say? It says let x1, x2, x3, x4 follow a joint distribution. Okay, this means that um, it means that this follows a joint distribution, and then it has told me that their joint PMF is given below. So this is the joint PMF. This is how you represent the joint PMF. We don't need so many variables. We don't need the joint PMF representation of so many variables. However, for the sake of completion, we are doing it. Okay, so don't be worried if you are not able to understand how these things work, although I'll be covering it. It says that if T1, T2, T3 and T4 are 0, that means if x1, x2, this is for the value x1, this is for x2, this is for x3, and this is for x4. Okay. It says that if x1 takes the value 0, x2 takes the value 0, x3 takes the value 0, and x4 it takes the value 0, then the probability that all these four values are 0, it's 1 by 8. Similarly, if x2 takes the value 1 and all the others take the value 0, then it's 1 by 8 again, and so on. If for example, if x4 takes the value 3 and then x1, x2, x3 they take the value 1 1 1 1, then it's 1 by 8, and you can see the entire PMF. This is how the entire PMF is given. Okay. The first question, it says calculate f of x1 given x2 equal to 0 and x4 equal to 0 when x1 is 1. So what is actually this thing? Okay, let's find it out. Just let me change the color. Okay, so we know that something given like this 0 comma x4 equal to 0 given 1, this is nothing but conditioning with multiple random variables. So what does this mean? As I told you, it is joint upon marginal. Okay, but for this, when it's for two variables, it will be joint upon joint. We'll see that thing. So what does this mean? Probability that x1 equals 1, x2 equals 0, x4 equals 0 divided by probability that x2 equals 0 and x4 equals 0. This is something that we have, okay, according to the normal definition. This is the case. So if we look at this place very closely, the values that x1 takes in the first three in the first three rows, it's 0, 0 and 0. So these three cannot be considered. But can these be considered for the first case? Yes, they can be. The second thing, x2 equal to 0, the value that x2 takes, it will be 0. Okay, so for this case, case and this thing cannot be considered. Okay, for x4 equal to 0, that means my value of x4, that means this one, this should be also equal to 0. Okay, so x1 equal to 1. Let me change the color. Yeah, so x1 equal to 1, x2 equal to 0, x2 equal to 0. Do we find something like that? No, we don't. And then x4 equal to 0, we do find it. But if we see closely, then the values of x1, x2 and x4 are given are given to us as 0 0 0, then 0 1 0, then 0 1 1, sorry, 0 0 0, then 0 1 0, then again 0 1 0, then um, it's 1 1 3, then it's 1 um, 0 2, then it's 1 1 1, then it's something like 1 1 0, and then it's 1 1 and 1. So these are the values that are given to us. But what do we need? We need a value 1 0 and 0. We are not considering the value of the random variable x3 at this place. Okay, so if we are not considering it, then we can see that there is no such value in the given PMF table, neither this nor this, forget about these, okay, and neither this, which pleads our case. So if it does not plead our case, okay, let me write it in the next page. Yeah, since from the PMF table given, we do not find any case with which the given condition goes. Hence, we can conclude that x1 equal to 1, x2 equal to 0, and x4 being equal to 0 is an impossible event. Right? It's an impossible event. Sorry. So, since it's an impossible event, hence probability of E, which is probability that x1 equal to 1, x2 equal to 0, x4 equal to 0, that is equal to 0. So anything divided by 0 for this case, let's find out this case as well, which will be, and hence it will be easier for us. x2 equal to 0 and x4 equal to 0. We do have one here, and we don't have anything other than this, right? So it's 1 by 8. So it's nothing but 0. So this is the answer. Okay, all right. This is the answer. So this is all that we have from the first part. Now there is a second sub part of the question as well. Okay, if I have to find this option, choose the correct option. You can see the answers marked. So let's discuss. So let's discuss it one by one, so that you can get a clarity of how are these things done. What is tx1, tx2, tx3? Tx1 is the range of values that the random variable x1 takes. Okay. Similarly, x2, you just replace x2 here and this. then x3, this thing happens. Okay, I hope that you understand this thing. Okay, all right. So this is what we have for t. So from the PMF table, let's visit the PMF table once again. So the range of values that x1, x2 and x3 they take, what are those values? Does x1 take 0? Yes, it does. Does x1 take 1? Yes, it does. Does x2 take 0? Yes, it does. Does x2 take 1? Yes, it does. Does do x2 and x1, do they take any value apart from 0 and 1? No, they don't. For x3, does x3 take the value 0? Yes, it does. Does x3 take the value 1? Yes, it does. Does it take any value apart from 0 and 1 according to the PMF table? No, it does not. Right? So since it does not, we can say that this option is correct. And it's also told us that tx4 equals 0, 1, 2, 3. Let's see it again. Does x4 take the value 0? Yes, it does. Does x4 take the value 1? Yes, it does. Does x4 take the value 2? Yes, it does. And does x4 take the value 3? Yes, it does. So if it does for all the 4 events, then this is also correct. Hence, option A is correct. Second thing, tx1 equal to tx2 equals 0, 1. Yes, this is correct. tx1 equal to 0. No. x1 does take the value 0 and 1. And if I consider this statement to be correct, then I am considering this statement as false. And if I consider this statement to be correct, I am considering this statement as false. So it's a contradiction, right? So this won't be the case. Second, the third option, range of x1 given x2 equal to 0 is 0. What do I have to do here? I have to find the values of, don't look at this, now look at this one. And then this is x4, which is irrelevant to us. I have to find what values does x1 take when the value of x2 is given to be 0, if I'm not wrong. Yeah, 0. Okay. So x2, it takes the value 0, x1, it takes the value 0. x2 takes the value 0, x1 takes the value 1. And there is no other value, or there is no other case when x2 takes the value 0. Hence, tx1 tx1 given x2 equal to 0, that is only the value 1, right? So let's see what it says to us. It says 0. No, it's 1. So this is the wrong option. Then range of x2 given x1 equal to 0, comma x3 equal to 1 is 1. What does it say? When the values that x2 takes when x1 is 0 and x3 takes the value 1, then what is the matter? Okay, let's see. x1, it takes the value 0. Sorry, just a minute, forgot the data. Yeah, x1 takes the value 0, x2 takes the value 1. x1 takes the value 0, x1 takes the value 0, and x2 takes the, x3 takes the value 1. So x1 takes the value 0 here, x3 takes the value of 1 here. So x2 takes the value 1. Okay, this is the only case which I can see. Okay, anything else? No, I don't have anything else. So is it correct? Yeah, it is. Hence, this is the case. Alright, I hope that you understood this thing. I did leave a page blank, but it's not necessary. Okay, we do have another question related to this. So let's move on to that question. Let's discuss that question. It says, the question says, question number 3. Okay, calculate probability x3 equals 1 comma x4 equals 1 given x1 equals 1 comma x2 equals 1. Now what is this? As I said, it will be nothing but f of x1, x2, x3, x4, 1, 1, 1, 1 divided by f of x2, not x2, x1, x2. Yeah, okay. F of x1, x2, 1, comma 1. Alright, okay. So, in which case do I find all the values to be equal to 1? Let's visit the PMF table again. This is the case. Right? This is the case. All the values are equal to 1. So what's the value in here? The probability, it's 1 by 8. So what will I do? I'll be putting the value of 1 by 8 here. And f of x1, x2, which take the value 1 and 1 respectively. Okay. So x1 and x2, which take the value 1 and 1. Let's see how many cases can we get. One case is this. Okay. Just focus on the first two values. The second case is this. It's again 1 by 8. The third case is this. It's again 1 by 8. So it can be either this case or this case or this case. And as we know by the fundamental principle of counting, the or thing is written by plus and the and thing is written by multiply. That means if we have to combine two events, the probabilities, then it will, and if two events occurred simultaneously, then we have to multiply the probabilities, and if two events they occurred in a odd manner, or if they occurred independently, or the user or the person who is involved in the event, if he or she has a choice, then it will be nothing but the addition of the probabilities of these three events. Okay. Similarly, we have done something like this, and if we add them up, then it will be 1 by 8 plus 1 by 8 plus 1 by 8. That's 1 by 8 divided by 3 by 8. So 1 by 8 into 8 by 3. Okay. So if we cancel it, the answer is 1 by 3, and that's all. Okay. I don't know what's happening to my device, but okay. So this was a revision of the previous class, of the previous week, of the previous content that we had studied, and this was all that we had studied in the previous class, if you remember. So now let's start off with a new topic. What is that new topic? Independence of two random variables. Suppose one random variable, you have done it already. Okay. One random variable represents some event E1 going on. For example, um, a random variable x represents a number that I will be getting if I throw one die. Okay. And the random variable y, it represents the number that I will be getting when I throw two die, the die number 2, the other die. Since these two values are completely different or are completely independent, these two events are completely independent, I can say that these two random variables are also independent. Keep this example in mind. Okay. And now, analogous to the examples, we have got some analysis that I have written here. That's all. As I told you, statistics is not tough. The language might be tough, but if you relate with analogies, things are not that tough. Okay. It says two random variables x and y. Okay. The first die value and the second die value are said to be independent if the occurrence of one does not affect the occurrence of the other. If I throw the first die, I get a number 6, then will it affect my second die's number or the probability of getting a 6? No, it does not. Okay. Unless if I throw them together and they end up colliding. So that's a very realistic case which we are not taking. because I believe that we are capable of throwing two dice independently and safely. Okay. Mathematically, if x and y, this is important. If x and y are two independent random variables, then probability that x equals small x, that means x takes a value small x, and y equals small y, that is y takes a value small y, is equal to the probability that x equals small x and probability that y equals small y. Now what does this mean? Let's analyze it. We knew this thing, right? We did discuss that probability A intersection B equals probability of A multiplied by probability of B for independent events. We knew this thing. We knew this thing beforehand. But what has changed at this point of time is the way we express it. We are now not expressing events. We are expressing these events in the terms of random variables. Okay, so that is what we have written here. And if you remember, this next point is something that people do find tough to comprehend. At least in my time, I did find it tough to comprehend. So I would request you to pay attention to this thing. What does it say? Um, if we have a joint distribution, okay, let's take a simple example, not the die example, because we don't have that much amount of space in order to cover up things. Okay, so if we toss two coins and T1 is the value taken by the first coin and T2 is the value taken up by the second coin. Okay. Then according to this thing, if I form my PMF joint PMF table, it's 0 and 1 here. Remember the previous class, and it's 0 and 1 here. So this is 1 by 2, sorry, not 1 by 2, 0, 0. So 1 by 2 into 1 by 2, 1 by 4. This is 1 by 4. This is 1 by 4. This is 1 by 4. Oh, sorry. What did I do here? This is 1 by 4. Now, if I take up the marginal, what is the marginal? If I consider that I am getting 0 in my first dice, okay, sorry, not in my first dice, in my first coin. If I'm getting a failure of, say, tails, and if I take up that thing, what is this along? This is along my x-axis, sorry, this is along my y-axis, okay, and this is 0, y-axis, sorry. This is the value when y takes the value 0. This is the random variable along, these are the values along y. We know it already, right? Okay. So this is 1 by 4 plus 1 by 4, that's half. Similarly, for this case, it's half again, needless to say. And let's replace this 0 with the value of t2, because this is something that we have to do. And fx, that means the values when x, the value of the variable x is kept as constant and it takes a value t1 at an instant, it's 1 by 2 here and it's 1 by 2 here. Okay. All right. So do you understand or do you analyze something? F of xy t1 comma t2 is equal to f of xy t1 into f of, sorry, f of x, it's not f of xy, it's f of x into t1 when it takes the value t1, and this is y, it takes the value t2. Why? 1 by 4. 1 by 4 is equal to fx t1, fx t1. So fx for 0, it's half, into fy for 0, it's half again. Okay. Similarly, 1 by 4, fx for 1, fx for 1. If I consider the case of 1, 0. Okay. So 1 by 4 equals half multiplied by half for this case as well. Okay. So this thing is universal. Okay. And that's what I have written here. What have I written? First, take up the joint distribution, write out its joint distribution, draw its joint distribution, draw the joint distribution of the two variables, and then find out their marginals. And once you find out their marginals, you'll be seeing that and this is the case for two random variables to be independent. Okay, all right. So that is what it's written. Normally, fxy, when x takes the value of t1 and y takes the value of t2, is equal to fx. Okay, it has taken the value of t1 multiplied by the probability. What is this? This is the probability, right? This is a distribution of probability multiplied by fy such that x equal to t1 and it takes the value t2 right now. Like what is this? For example, if I don't write it as this, if I take this thing fxy t1 comma t2 equals fxy, or I should say something like this. This is something like probability that x equals t1 comma y that equals t2. Okay. Alright. So probability that x equals t1 given um, y equals t2 given x equals t1, probability that y equals t2 given x equals t1 is equal to probability that x equals t1 comma y equals t2 divided by probability that x equals t1. So if I send this to the left hand side, if I multiply both sides, then this is something that I'll be getting, right? Okay, this is what I am saying till now, and this holds for two random variables being dependent. However, for the independent case, it is fxy such that x takes the value t1 and y takes the value t2 is fy equals fy t1 multiplied by fx t2. What I did here, you can change it. I have taken a different notation and you can take a different notation as well. Okay, all right. Fy t2, why have I written here fy t2? Because fy, it takes the value 0 and I mean fy, it takes the value 0, y takes the value 0 here, and I have to run for this entire margin. That's all, nothing fancy in here. And it can be written otherwise as fy given x equals t1 such that y takes the value t2 is fy t2. Why can it be written like this? Because this event, it does not care if it depends on y or not, or if y depends on it or not, because y is independent. And since the value of y is independent, it can be written simply as fy t2. Okay, not a big deal. It's that easy. So despite this event occurring and despite this event not occurring, this thing is something that will be permanent. Okay. Alright. So even if it was given something like fx given y equals t2 and x takes the value t1, that will be fx of t1. Okay, that is what it will be written. So this is the entire thing. Okay, alright. Now let's do some questions. What does it say? It says, again, let me change the color of my pen. Yeah. It says that mm, let x comma y follow the joint distribution of fxy t1 t2. Choose the correct statements. Alright. It's factual. You see, if fxy t1 t2 is not equal to fx t1 into fy t2 for some t1 belonging to the range of x and t2 belonging to the range of y, then x and y are dependent. Yeah, that's true. That's what we have studied till now. If these two things are equal, if this is equal, then they are independent. And if it's not equal, then the values x and y are dependent on each other. Okay, all right. Second, fxy t1 comma t2 equals fx t1 into fy t2 implies x and y are independent for some t1 belonging to tx and t2 belonging to ty. No, it's not. Right. Why it is not? Because it's independent. And if it's independent for some t1 belonging to tx and t2 belonging to ty, it's not implying that all the values will belonging to tx. Right? It's not implying that all the values will belonging to ty. So it might occur for some cases, for some very special cases, but it's not overall true. It's not universally true, which denies a definition. Okay, so this should have been, just a minute, if it would have been for all, then it would be correct. Otherwise, it's not correct. It's incorrect. Hence, this option is incorrect. C. fxy such that x takes the value t1 and y takes the value t2 is equal to fx such that it takes the value t1 multiplied by fy such that it takes the value t2 for all t1 belonging to the range of x and t2 belonging to the range of y implies that x and y are independent. Yes, for sure. That's what we have studied till now. And then D, if x and y are independent, then if y given x equal to t1 and y takes the value t2 is fy of t2. Yes, that's something we have studied. Despite this event occurring or not occurring, this value will be constant. Hence, this is also an answer. Okay, so the correct answers are option number A, option number C, and option number D. Okay, all right. Then the next question. What does it say? It has given us a PMF table, a joint PMF table. Okay, and it has given us some questions, some statements, and out of these we have to choose the correct options. So let's see. It has given us T1 taking the values 1, 2, and 3, and T2 taking the values 1, 2, and 3 as well. Okay. So what will be my tuples? It will be 1, 1, 2, 1, 3, 1, 1, 2, 2, 2, 3, 2, 1, 3, 2, 3, and 3, 3. Right. This will be the entire thing. So what if I do something like I take the value here fy of t2 or let me do it in the next slide. Okay, just a minute. Yeah, let me do it in the next slide. I do have a lot of space in here. So T1, sorry, very sorry. Yeah, okay. T1, and this is the values that T2 takes. These are the values. Okay. All right. So 0, not 0, 1, 2, and 3. It's 1, 2, and 3. What are the probabilities? For 1, 1, 1, 2, and 1, 3, it's 1 by 4, 1 by 4, and 0. So let's write them down. 1 by 4, 1 by 4, 0. The second thing, for 2, 1, 2, 2, and 2, 3, it's 1 by 16, 1 by 8, and 1 by 16. So let's write them down again. 1 by 16, 1 by 8, and then 1 by 16. For the third tuple, it's 1 by 16, 1 by 8, and 1 by 16. Okay, so let's write them down. 1 by 16, 1 by 8. Is it the same? Yeah, it is. 1 by 16. Okay, just a minute. Got numbers here. Okay, right? All right, all right. No problem. No problem till this part. Then Fy when, or yeah, the values, the sum of probabilities when y takes the value 1, it is 1 by 4 plus 1 by 16 plus 1 by 16. So it's 4 plus 1, 5 plus 1, 6. So it's 6 by 16. Similarly here, 4 times 2, that's 8. And then it's 2. 2 plus 1, 3 plus 1, 4. 4 by 8. This it's 2 by 16. Okay. Then fx of t1. 1 by 4 plus 1 by 4, that's half. Then 1 by 8 plus 1 by 8, 1 by 4. Then 1 by 8 plus 1 by 8, 1 by 4. Okay. So now that we have the entire distribution, now we can see, just for the verification, 1 by 4 plus 1 by 4, it's 1 by 2, and it's half, so it's 1. And similarly, 6 plus 4, 10, 10 plus 2, sorry, 6 plus 8, 14, 14 plus 2, 16, so it's 16 by 16. So this is 1, and hence our calculation is entirely correct. Okay. What has been told to us? The first option, f of x1, x2 at 1, 2. Does this hold? So let's check. F x1, x2 at 1, 2. F x1, x2 at 1, 2. What will it be? Let's break them down. If, and that is fx1 at 1 multiplied by fx2 at 2. Okay, all right. So fx1 at 1 multiplied by fx2 at 2. What is fx1 at 1? It's 6 by 16. 6 by 16 multiplied by fx2 at 2. Fx2. So this fx2, or let's do something. This is fx2 at 2. This is fx1. So let's rewrite it. Fault on my side, costed you some time. Sorry about that. Okay. So fx1 at 1. Fx1, when it takes the value 1, it's 1 by 2. And fx2 at 2, that is when x2 takes the value 2, it's 4 by 8, which is again 1 by 2. Simplifying it, we get 1 by 4. And what is f of x1, x2 at 1, 2? X1 will be 1, x2 will be 2, it's 1, 4. Oh, dearie me. It's same. And hence, we can say with a big smile on our faces that, yeah, this is the correct option. Second option, f x1, x2 at 1, 3. Does this hold the case of independence? Let's see. Let's see. F of x1, uh, f of x1, x2 at 1, 3, that is f of x1 f of x2 multiply. This is something that f of x1 at f of, and f of x2, and x1 takes the value 1, x2 takes the value 3. Okay, this is something that we are given to verify. Okay, so x1 at 1, again it's half, and x2 at 3, x2 at 3, it's given 1 by 8, that is 1 by 16. Now at 1 comma 3, let's see, x1 will be 1 and 3 it will be 0. My goodness, it's not equal to 0. Hence we can say that no, in no century will it be correct. Okay. Then it's told to us x1 and x2 are independent. Are the values x1 and x2 really independent? This is a fault from my side, so please, I'm sorry. Okay, x1 and x2 are independent. Does this case hold for all the values? No, it does not. We have just seen that it does not hold the case for 1 and 3. Then how can I say that these are independent? So hence the correct answer will be no, these are not independent. Simple as that. Okay, all right. And then question number 3. What does it say? It says let x and y be two random variables such that f of x given y equal to t2 and x takes the value of t1 equals 0.02. So let's write it down. Writing down a data during a problem sum is a very good practice. You should always follow it. And the marginal PMF of Fy T2, Fy taking the value T2 is 0.6. So Fy taking the value T2 is 0.6. Okay, there is one confusion. Don't get confused for the capital F and the small f. Okay, especially as of now. You will be getting confused in the later stages because when we'll be studying cumulative distribution, then things will be becoming complicated and tough. But as of now, capital F and the small f, they are the same. Okay, all right. Then it's given to us for T2 belonging to Ty. Okay, and calculate f of x of T1. This is something that we have to calculate. Okay, so how will we calculate this thing? All right. Okay, so if we have to calculate this thing, then let's keep one thing in our mind. We knew a formula, right? What was that formula? F of xy, which takes the value of t1 and t2, that's equal to f of x when it takes the value t1 multiplied by f of x given y equal to t2. Y equal to, just a minute. What's happening to me at this case? So f of x given, just a minute. The marginal is given, right? So this will not be the case to follow. What this is telling to us? Okay, it told me that the two random variables are such that this is equal to 0.02 and the marginal PMF of this thing is 0.6. Okay, and hence I have to calculate the value of T2. Hence I have to calculate the value of Fx given T1. Okay, now here nothing is told to me about the independence or the dependence of the random variable. Okay. So if it's not told to me, hence I cannot conclude that if they are dependent or not. All right. So if I cannot conclude that thing, then how will I be able to proceed with my question? Look, there are two methods. First, we can assume x and y to be dependent. So in that case, f of xy when x takes the value t1 and y takes the value t2, it will be f of x when it takes the value t1 multiplied by f of y when it takes the value y given x equals to t1 and y takes the value t2. Okay, this will be the case. But if we do this thing, okay, if by any chance we are able to find out this thing, the joint distribution is not given to me. Right? This thing is not given to me, and this one is unknown as well. This is something that we have to find out. And hence, it will be very unfeasible for us to assume this. Because when the data is not given, how am I supposed to find out? And if I take the second way, that I assume x and y to be independent, then it will be f of xy t1 comma t2. That's equal to f of x into f of x t1 into f of y t2. And another formula is f of x or f of x such that y equal to some value t2 and x takes the value t1 is f of x t1. Okay, these two are the formulae that we can apply or we can imply. And if you notice closely, they have done a very clever job. What have they done? They have given us this thing indirectly. So, according to me, according to my solution, I might be wrong. But according to my solution, assuming these to be independent will be a better approach because we don't have the data for this case. So, if I assume this value, then it will be 0.02. Okay, so 0.02 it will be fx of t1, and this will be my answer. Do you get me? This will be my answer. This is a very tricky question. Okay, so for questions like these, what is the blueprint? The blueprint is number one, assume dependent, then analyze, and once you analyze it, um, find the accurate data if you can. And if you are not able to do so, then the second approach comes in, which says assume independent, and then once you assume independent, apply formulae, and once you have applied the formulae, get the answer. Okay, so this is all that you have to do. This is a two-step method. Okay, all right. So this was a good question, and I would genuinely recommend you to keep it in your book list and do revise it. This is an important question. Okay, all right. So let's move on to the next topic. The next topic is identical and independent distribution. Now you will be studying about this in detail in week number 7, but here we have got a very specific case of identical and independent distribution. Is the geometric distribution. Okay, the geometric case of identical and independent distribution. But I do doubt that if questions will come from it or not. There's only one formula for this. You can see it right on your screen, and I'll be explaining it to you within a few minutes. Just bit correction needed. Yeah. So I'll be explaining it to you within a few minutes, and this formula is something that you have to remember. What does it say? First of all, what is an identical and independent distribution? Till now, we have been dealing with only two variables, okay, x and y, or x1 and x2. And then we have been dealing with conditioning of multiple random variables. But we have been dealing with two variables generally till now. Okay, all right. So now what we have to do is we have to deal with several variables, say 10 variables, x1, x2, and so on till x10. And we have to assume that they are identical and they are independently distributed. What is this? What does this mean? It means that these variables x1 to x10, these will be identical in nature, or this will be having identical distributions, and this will be and these will be independent. What is identical distribution? If x1 follows Poisson distribution, then x2 must also follow Poisson distribution, and x10 must also follow Poisson distribution, and any variable, any random variable coming in between these must follow the Poisson distribution. Okay, all right. So this will be identical distribution. What is independent? These two values, these two should be mutually independent. What have I said? x1 and x2 must be independent, x2 and x3 must be independent, x1 and x3 must be independent. So if there are 10 random variables, then the number of independences that we have to check, although we don't, but just for a normal answer, it will be 10c2. So it's 10 factorial divided by 2 factorial into 8 factorial, which will be nothing but let me grab my calculator because I'm not into this devious calculation. Divided by, I can, but who does want to if they have got a calculator in their hand? Okay, so it's 45 independences that we have to check, or these are there are 45 ways in which these values are independent of each other. Okay, so that is all about identically and independently distributed random variables. Okay, all right. Just let me clear the screen a bit. Mm, yeah, okay. So what does it say? It says if the random variables x1, x2, and so on till xn are said to be identically and independently distributed, or IID. they generally mention it as IID. So IID means identically and independently distributed. Okay. So they are called IID variables if they are independent and they follow the same distribution as I told you. Okay. Now there is one very specific case. This is a very specific case. Don't worry, you will be studying about these values following normal distribution, then Poisson distribution as we progress. Maybe in week 7, week 8, week 9, week 10. Things will be brought up to you. But if you understand this one concept perfectly, then that will be a cakewalk. That's a cheesecake for you. Okay. Especially the first, these two things. People do forget these things. They tend to understand these things right now, but after a couple of weeks, it's all empty. So don't be like that. Okay. Now it says that if x, what is x? Or I should say xi. That means x1, x2, x3, all these xi's, if they follow a common geometric distribution with a probability p. What is geometric distribution? Geometric distribution, it says the number of trials required to get of to get the first success. To get the first success. And P, it represents the probability that these are the number of trials. For example, I would need 20 trials of this event to get my first success. I would be flipping the coin 20 times in order to get my first success, and I will be having a probability for that thing, and that will be represented by geometric P. Okay. If you want some detailed discussion, then you must visit week 0, Celestine geometric distribution in a very fun manner, and you will be able to understand it. Okay. Then the probability that x1 is greater than some value j, x2 is greater than some value j, and so on till xn that is greater than some value j, that will be equal to probability that x1 greater than j into probability x2 greater than j into probability x3 greater than j greater probability xn being greater than j. And since they follow the same value, the same thing, okay, since they follow the same thing, they will be following 1 minus p raised to the power j, because this will be the value or the probability for one trial. Remember this. For probability x1 greater than j will be 1 minus p raised to the power j. Okay. Okay. And if it's repeated for n times, so plus j plus j plus j, so it will be j times n or n times j, however you want to put it. So this is the entire thing based on geometric distribution. Now let's apply it, and then we'll be able to understand that where is it applicable. The question, it says let x1, x2 and so on till x10 follow identical and independent distribution with a geometric value of probability 1 by 5. Now find the probability that x1 is greater than 10, x2 is greater than 10, and so on till x10 being greater than 10. So probability x1 greater than 10, x2 greater than 10, and so on till x10 being greater than 10. That will be, now let's generalize it. Okay, probability x1, we knew that probability x1 being greater than j, x2 being greater than j, and so on till xn being greater than j. So here for this case j, okay, j, for this case it's 10. Okay, all right, and n for this case it's again 10. So what was the value? What was the probability? It was 1 minus p raised to the power of j times n. So it will be 1 minus p raised to the power of j. What is j? It's 10. And what is n? It's 10 again. So 1 minus 1 by 5, since this is p. Okay, 1 minus 1 by 5 raised to the power of 100. So it's 4 by 5 raised to the power of 100. Okay, and this is the answer. Calculate it for yourselves in order to get the correct or the answer to the decimal point. But I don't think it's required. It will be a very nasty answer. Something, if I express it in the scientific notation, it will be 0.8. Sorry, 0.8 into 10 raised to the power minus 100. So it will be approximately something tending to 0, but okay, it's not 0 for our case. Alright. Now, this is a new type of question. What does it say? It says the PMF of a random variable is given as probability that x equals xi. That means xi is some value. Okay. And x1, and this takes a certain range of values. Okay. And xi is nothing but the value that is given here, just for your clarity. So the probability is 0.1 when x takes the value -2. Probability is 0.3 when x takes the value -1. The probability is 0.1 when x takes the value 0. And the probability is 1 when the probability is 0.2 when x takes the value 1. And the probability is 0.3 when x takes the value 2. Okay, this is the entire breakdown of the PMF table. Now what does it say? It says let y equal to x multiplied by x squared minus 1 multiplied by x minus 2. Find the range of y. Okay, so first let's do one thing. Let's draw the table. Let's draw the table and then we'll be talking the rest. We know how to draw it, right? We have done it in our statistics 1, I believe. At least I have done it, and if you have not, then you must go and revise. It's -2, -1, 0, 1, then 2. 0.1, this is 0.3, 0.1, 0.2, and then 0.3. This is something known as the probability distribution table, the probability mass function. Okay. Now it has been said that y equal to x into, let me write it below, y equal to x multiplied by x squared minus 1 divided by x minus 2. Okay. So if this be my value that y will be giving me, and this be my value that x will take, then what values can I get? Put x equal to -2, it will be -2 into 2 squared minus 1, that's 3, into -2 into -2, that's -4. So 2 4s are 8, 8 3s are 24. It's 24 minus 2. Similarly, -1, and it's 0, and then it's 0. Sorry, it's -1. Then it will be. I know that it will be 0, but I'm just so it's -3. So for x equal to -1, the value will be the value. Sorry, just a minute. I have interchanged things. This will be written here. This is 24. Let me check it once again. Oh my god. Okay, so -2. So 4 minus 1, that's 3, and then -2 minus 2, that's -4. So minus, and so that's plus 8 into 3, 24. Okay. And x, it is minus 2. For x being equal to minus 1, it will be 0. Alright. For x being equal to 0, it is 0 again. Okay. And for x being equal to 1, okay. For x being equal to 1, it will be 0 again. Okay. X being equal to 1, y is 0. And for x being equal to 2, it's 2 into 2 minus 1, 1. So 2, it's 0 again. So as I can see from this PMF table, the range of y, that will be 24 only. Sorry, 24 and 0. That will be 0 and 24. Okay. This is what my range will be. Okay. All right. So now if now for y equal to 0, what will be my probability? This will be 0.3 plus 0.1, 0.1 plus 0.3, that's 0.7, 0.9. Okay. So this will be 0.9 and this will be how much? For 24, right? So for 24 it will be just a minute, let me cross check with this x into x squared. Yeah, okay. So it will be 0.1. So this will be my range. This will be my range for y. Okay. And now we've got another topic. Let's move on. It's function of two random variables. Now what is this thing? We have done something like x plus y. We have done something x minus y, x times y. These are all polynomials, not polynomials, but single variable, or not single variable. This is linear, this is linear, and this is a two variable structure. We have done it till now. Okay, we have manually added two values, we have manually subtracted two values, we have manually multiplied two values. We have also manually divided two values, right? Okay. So once we have done all these, now if x and y are variables, random variables, then if I define a function z, any variable, any other variable, z as x plus y, this will be called as a function of two random variables. Why? Because the value of z depends on what value x takes and what value y takes. Okay. So this is what we call a function of two random variables. And if I am to read this, a function defined on two random variables such that its PMF is defined by the joint distribution of these two variables is known as a function of the two random variables. For example, z equal to x plus y, where x and y are two discrete random variables. Now what does this mean? It means that if I have that old coin toss example, then this will be my PMF. Just a minute. This will be my PMF. Okay. So since this will be my PMF, it will be 0, 1, This will be 0, 1. Okay. So it's 1 by 4, 1 by 4, 1 by 4, and then 1 by 4 as well. Okay. So since it's 1 by 4 for each, I know that the values that z can take is either 0 or 1 or 2 if I define z as x plus y. But what value will z be taking when it's 0? It will be something which will be given by this, this distribution. What will be the value of, what will be the probability when z takes the value 1? It will be given by something like this. We know all these, right? Addition and multiplication of probabilities. We have discussed it in today's lecture as well. Rewind it if you didn't know. Okay. For this case, fxy 1 comma 1. Simple as that. Okay. So fxy 0 0, what is written here? It's 1 by 4. Fxy 0 1, fxy 0 1, it's half. Fxy 1 1, it's 1 by 4 again. So my PMF of z, it becomes 0 1 2, and this will be 1 by 4, half, and 1 by 4. Okay, and this is the probability of z. That's it. That's the core concept of the function of random variables. When z is represented as a function of two random variables x and y. Okay, all right. Now let us do some questions and we'll be able to understand the same. What questions? Let's see. Now this thing will be a bit tricky, so I'd request you people not to panic, but to remember it as a factual data since it won't be that much evident. IITM has never asked it in their quiz examinations. They might not in the upcoming examinations as well, but it's important for us to know. It says if the random variables x and y represent the number of people visiting a mall in city 1 and city 2 respectively, and follow the Poisson distribution with x accounting an average visit of 10 people per hour and y with 20 people per hour, assume that x and y are independent and let z denote the total number of people in city 1 and city 2. Find the PMF of fz and z. How will I do this? You see, x is given to us as Poisson distribution following 10, and y its Poisson 20. Okay, all right. And z is told to me as x plus 1. So let's take it step by step. For 1 hour, my in my city A, only 10 people are visiting. And in the same time, for city B, 20 people are visiting. So in 1 hour, how many people are visiting in total? It is 10 people in city A and then 20 people in city B. And since the number is same or the distribution is same, I can say Z follows Poisson, which is 30, so it is Poisson 30. Okay, all right. That's all. That's it. Second thing, find the conditional distribution of y given that the total number of people visiting the shopping mall in city 1 and city 2 is 30. It was it was nothing to be assumed, but okay, they have given it to us, so let's assume. What what has been told to us? We know, okay, this is something that tricks people This is something that had tricked me. So we'll be accounting for it in a very simple manner, and we must not panic. Okay. We know that for Poisson distribution, if something is given, okay, Poisson distribution given a Poisson value, that always leads to a binomial value. Okay, this is a factual data. I didn't know this. I got to know this afterwards. This is a factual data. Okay, so why this? Why this thing must happen? Why should we follow this thing? You see, binomial, it has two parameters n and p. Okay, for n, I can put the value as 30 because the total number is given to me, and I can put the value of p. And here you can see that Poisson, it's given 1 by 3 and 2 by 3. What is Poisson distribution? It's a kind of binomial distribution, but a large number of trials and a very small probability success. That is called the Poisson distribution, such that n into p, it's a constant. Right? But if I am conditioning a Poisson variable with respect to a Poisson variable, then does it make any sense to call it a Poisson variable even? Because ultimately, I will be getting a value that will not be a Poisson variable, but it will be a binomial variable. Okay, because a majority of the chunk has been removed by the conditioning. So the large number is now limited to a finite number, and the probability does also satisfy that. Okay, so for this case, it's binomial. Okay, and now what is the success rate? It's simple. That this will be 20 divided by 30 because I know the total number of people visiting the um, shopping mall Y, because um, I know the value of Z and I know the value of Y, obviously. So that will be 2 by 3. So this will be binomial n comma p, which is binomial 30 comma 2/3. That is all. Okay, all right. And if you didn't understand this, please do let me know in the comments. I will be trying my level best to give you a clear-cut explanation with the help of words. Okay, not with the help of videos anymore. But I'll be trying to give you the best example and the best explanation regarding the previous question. Okay. Oh, and we have forgot to mark our correct option. That will be um, y given z equal to 30, and it follows finally. Okay, all right. Then we have got the question 6. What is that? What is it telling me? It's telling me the joint PMF of x and y is given as, this is the joint PMF. Now we define z1 as minimum of xy, z2 as maximum of xy, and now I have to find fz at 1 and fz at 2. Okay. So what values do I have here? X, let's tabulate it. Okay. X, y, xy, and then its minimum of xy, and then its maximum of xy. So for x, it's 0. Uh, let's write it in a tuple manner. Okay, so 0, 0, 0 1 0 2 1 0 1 1 1 2 2 0 2 1 2 2, and then it's 3 0 3 1 3 2. Okay, all right. So minimum is 0. This is 0. This is 0. This is 0. This will be 1. 1 0 1 2 0 0. Sorry, not 0. This will be 1 and this will be 2. For maximum, 0 1 2 1 1 2 2 2 2 3 3 and then 3. So the values that Z1 takes, that is 0 1 and 2, and the values that Z2 takes, that is 0 1 2 and 3. Okay, all right. Now for fz at 1, fz at or let me define the value z right now. Okay, let me define its PMF. So this is z, this is probability z, and for this is for z1. Okay, so that's 0, it's 1, it's 2. So for 0 0, it will be 0. So for the first uh, 3 values, it will be sorry, for the first 4 values, it will be 0. Okay, so 0 0 1 by 12, 0 1 1 by 12, 0 2 sorry 0 0 1 by 12, 0 1 1 by 12, 0 2 1 by 12. So that's 3 by 12, and then 1 0 yeah 1 0 1 by 12, 1 1 1 by 12, sorry 1 1 0 1 by 12. Okay, so it's 4 by 12 for 0, 4 by 12. All right. Similarly for 1, okay, for z being 1, it is nothing but 1 for the values for 1 1 1 2 2 1 and 3 1 1 1 1 1 1 2 1 2 2 1 and then 3 2. It is 4 by 12. Okay, so it's 4 by 12 again, and we know that since it's already done, so it's 2 by 3, 1 minus 2 by 3, that's 1 by 3, which will again be 4 by 3. We know that. Okay, z2, for z2, what will the value be? The value will be 0 1 2, sorry, it will be 0 1 2 and 3. Yeah, so let's write it down. 0 pardon 0 1 2 and then 3, and probability of z2. For 0 it will be only the first one, so it's 1 by 12, 1 by 12. For 1, for 1, okay, just a minute. Yeah, for 1 it will be, let me erase these annotations so that it will be easier for you to understand. Okay. For 1 it will be 0 1 0 1, then 1 0 1 0, then 1 1 1 1, then nothing. Okay, so it's 3 by 12. Okay, it's 3 by 12. For 2, what will the value be? What will the probability be? It will be for 2, it will be yeah, 0 2, then 2 0. Oh, we have got a long list of 2's here. Okay, so 2 0, then 2 1, then 2 2. Okay, 1 2, 2 1 2 2, and then we have got 1 2, 1 2. Yeah, so that is nothing but 4 by 12. 4 by 12. So that's 3 plus 4, 7, 7 plus 1, 8. 8 by 12, so 1 minus, that's 4 by 12 again, for 3. 1, why did I write 13? It's 4 by 12. Okay, alright. Find fz1 at 1. What is fz1 at 1? Fz1 at 1, that is equal to nothing but 4 by 12. Go through how I did it, okay? And the second one, what is it? What was the question? Find fz2 at 2. So fz2 at 2, that is nothing but 4 by 12. Okay, so with that, we come to the end of our lecture. Thank you very much if you are right till the end of the lecture and do revise these questions, and we'll be meeting soon in the next video. Till then, goodbye, tata, bye bye, take care, and keep studying. Thank you very much.